Right. So compliance meets SIEM automation. Essentially, the reason I wanted to do this talk is because I've been an application security specialist now for a while, but before that, I used to be in security risk and compliance. And during this time, I was working with a lot of security guys who are very much like audits, PCI compliance. So I was kind of like um, I was there as like the techie person, and the one thing I noticed was the fact that whilst these guys are great at like conducting audits and going through their various assessments, what would be even cooler is if some of the results they were producing, like whether it's compliant, non-compliant, if it was actually backed up by some of the logs. And obviously, like that's kind of started off like a whole big thing where I was working a lot with Splunk, working a lot with like SIEM and automation. So let's introduce myself first. As I already mentioned, application security specialist, moving jobs. So going to be an application security specialist for a whole 2 more days before starting as a DevOps security architect for AI, which might be the coolest job title I could possibly dream of. So again, security risk and compliance, did that for like an entire year, just essentially building dashboards, building applications in Splunk. Got quite a bit of a way into it, producing various reports and things for like CISOs and department heads. And again, just loving it, finding it quite interesting. At the same time, also doing some of the remediation work on various applications and systems as a whole. And like there's a big focus at the moment with like PCI compliance, where financial services are kind of taking off. And with processing card payments, obviously there's like certain criteria that need to be fulfilled. So a lot of my job was doing that. In my free time, I usually develop applications. I guess what started me off in tech is web development, so JavaScript, Node, React. Recently, also been dabbling in Java with Android apps. So yeah, kind of like developer in my free time. Quite fun. Special interest in quantum computing, so it's kind of I was applying for a role with IBM a while back, and they released a really I don't know if you guys have heard, but they've essentially got their own like quantum computer. But the cool thing is that they've got a tool called Qiskit, and they've essentially got a tutorial on YouTube online for how you can run simulations against this quantum computer. And if I think it's like if you pay some amount of money, you can actually run real simulations. So I thought that was quite cool. Some of the other things I'm interested in is getting girls into tech. So I've been like an instructor in web development and a speaker at one of the panels for Code Fast Girls. That was quite a bit of fun. So yeah, kind of that's kind of been my journey for the past few years. And now, why SIEM? So as mentioned before, again, there's like a move to a shift towards like cloud computing, big data, containerized platforms on various cloud platforms. So I guess the big thing with that is that all of this new tech is generating so much data, and I think there should be a bigger emphasis on actually understanding the type of data that's being generated and actually making the most of it. Because what I found is a lot of the time in industry, people tend to have the requirement to have like audit logs or just have logs going into a SIEM engine. But what they don't know is that there might be some overlap between like IT and security, or like data governance and security, in terms of like the data that's being used, or the way that's maybe one team did some analysis that could prove essentially useful for some other team. So yeah, that's kind of why I'm doing this talk. I think it would be really helpful to kind of get to the lowest levels of logs and kind of builds it up from there. Yeah, obviously, aggregating logs, things like that. But also putting it into the context of the wider business. So not just having, I don't know, security logs and have it being monitored by the SOC team. Have it actually see if those security logs are useful for things like compliance or finance or HR. Sometimes it is. For example, like I guess if a user like user onboarding and deprovisioning. Obviously, there's like systems that need system permissions that need to be revoked at the same time as HR like gives notice. Yeah, doing like the emphasizing things like that. So, what can we learn from log data? This is essentially a list of the different logs that I've come across, things I found useful, and things I've used in the past to do things like tracking down users, building meaningful data, and showing like results for various remediation projects to show that a system actually has improved in its security. So, like the biggest thing for me is the Active Directory server logs. So obviously, when a user signs in, generates a log event, and yeah, that's just kind of that. What I started doing at one point is actually using the Active Directory groups that we had a list of. So I think the idea is that you have a list of Active Directory groups and users that that belong to certain groups. And then you also have logs generated when those users access certain systems. For example, let's say there is a database that's being accessed and it's being governed by an Active Directory group. But the user, you look at like the past 30 days and you find out that the user, even though they're part of that Active Directory group, they haven't actually used that database in like over 30 days. So that's when things like Splunk come in useful, where you can essentially generate a ticket off the back of that. Use like the two comparison lists, and for anyone who hasn't accessed a particular system, have it automatically deprovision the user. So that's something that's quite easy to do, but in practice takes like done manually, it's just a huge headache for the provisioning team. So yeah, automating things like that. And then there's obviously like OS system logs for tracking down IPs, correlating IP addresses with host names. And then one of the most useful ones, I think, is the security tool logs, because a lot of it, they do a lot of the analysis themselves. So things like BigFix, things like CrowdStrike. You can essentially tell a lot. They essentially like analyze the endpoint, and they can tell you how it's configured, how many like what kind of users are signing in, whether or not it's a machine that's like got a lot of vulnerabilities, like if you get it with Qualys. So you can use all of those different tools to make sure that the configurations on a particular machine are correct. For example, like a version number, whether or not it's got automatic patching. Yeah, and in terms of like, again, tracking down users and tracking down like service owners, things like that, network logs are just so useful, just because essentially like type in an IP address and you can see what kind of traffic that IP address is getting, and then you can build out a whole map of your system that's kind of like, I guess, almost live if you run the query. Yeah, and then obviously application logs, things like is that user actually supposed to be doing like CRUD operations? Are they allowed to be deleting databases, things like that? Why are they deleting databases if we didn't think they had permissions to delete databases? and then obviously DB logs. So yeah, lots of like, as you can probably tell, there's lots of different sources, lots of different streams of data. So if we actually look at Splunk, I don't know, you've probably seen these before, but what I've essentially done is load in the tutorial data, and that is quite easy to get hold of. It's just on the Splunk website. Download a literal zip file, and then what you've got is a store that's essentially a demo version of a real shop with different like sources, with different users, including. Okay, let's see. Right. So tutorial data. What have we got here? We've got sources. We've got the web access logs, we've got mail server logs, and sales data. Fine. Again, vendor sales. What I'm actually interested in for now is these things. So the point at which that this is, again, raw source. What you can do is look up the actual URL that users are accessing, and then it gives you things like the query they used, what browser, things like that. Pretty simple stuff, really. The shop is called Buttercup Games. So yeah, that's the data. Let's see. So some of the actions here. Someone's clearly done some analysis into what the queries look like when someone actually does these certain actions. So let's try. Action equals purchase. So we can do things like seeing from which IP addresses have been making the most purchases. Cool. So that's single logs at the moment, single log events. Where it actually does get interesting is where you combine events to get relationships. So this is the definition I pulled up online from some security tool. It says that event correlation takes data from either application logs or host logs and then analyzes the data to identify relationships. So application logs or host logs, I'd say just logs in general. I think the key bit is making sure that you're viewing the events as part of like a trend and as part of a pattern rather than as individual events. So things like using timestamps, users, server IPs to trace a user's actions over time. And I don't know if you guys are familiar with like security forensics, but if a machine has been compromised, they obviously take a sample of the logs and see at which point the machine has been compromised by looking over which IP address has been been known to go into a system, and then seeing which account credentials it's been using. So, for example, if an external IP has been generating a lot of traffic and ended up getting like a root password after like generating tons and tons of traffic, you can probably tell it's like a brute force attack, things like that. You can also trace who's been accessing a server to find product owners. So that's something I've done in the past, again, using network logs, using security tools. I think the key bit for me was being able to go find information from one log and then use that information in a different log, if that makes sense. So finding out, for example, that the host name is correlating to some IP address, and then finding that IP address via like SMB or HTTP traffic in the network logs. So that's been really good. And then things like making sure that the security tools you guys are using are actually accurate, that they're scanning everything. Is there anything like missing from the security tool? Why is it missing? And then also like, what is it doing its job well? So at this point, you'd be looking into how much like CPU usage the scans are taking, whether or not it's too much. Yeah, essentially like proving the worth of the security tool and seeing if there's any improvements from looking at the logs. So let's look into doing some event correlation on a user. So here you can see I did like an example earlier, but we can use a different IP address for this. What I essentially want to do is track an IP address to see what kind of actions it's been taking over time. So let's do an external one. That one seems quite interesting. And that is the, I believe, client IP. Yep, let's do. Cool. So let's take away the action equals purchase. Right, so looking over, let's see, what date is that? 23rd of August. Let's look at what they've been doing the 23rd of August. I think that might be when I downloaded this data. Right, so you can see on that, they've been browsing this product, went to the sports section, and then made a purchase from that. And then they made another purchase, and yeah, added. The weird bit is that they didn't actually add anything to cart before they made a purchase, but fine. So fine, tracing a user. That's done. The difficulty comes when there isn't enough information in the log. So in this example, we can see receive disconnect from, let's see if I can make this bigger. Cool. Receive disconnect from 10.3.10.46, disconnected by user. However, we can't actually trace this back, and that's quite significant for if we're looking into doing any kind of compliance. Obviously, if we're looking to do an audit, we'd like to be able to know who's accessing the internal systems. So let's search by 10 dot anything and look at the internal accesses. Receive disconnect from 10.0.3.46. So same thing. However, that doesn't tell us much. User isn't very helpful by itself. So what we're going to do is if it works, receive disconnect, fine. Cool. So how are we going to get around this? Well, let's see. Need to get that query. Probably should have planned for this. Let's just extract some fields. So, tutorial data, looking for the password4 field, looking for the internal IP and whether or not it's been passed or failed. All time. Cool. So here we can see I'll just show you some of the fields we're pulling up. Essentially, these rex bits are classifying the password. What are they doing? They're essentially pulling out everything after that says password 4 and classifying everything that's after that phrase as the user. So you can see password 4 and sharp password 4 muon. Fine. And then got the internal IP and whether or not it's passed or failed by just pulling that up. Cool. So how are we going to track down that user? We're going to do stats values internal IP by user. So we've classified the fields fine. The IP address we had earlier that we didn't know from who it was, 10.3.10.46, we can now tell that D Johnson has disconnected. And if you wanted to add that logic in, all you'd have to do is save the search and have the map ready, or even build it into Splunk as an additional like extracted field. Cool. So we can trace a user. And then the next bit from that is seeing, so classifying by every single user how many failed and accepted passwords there are. So just taking it that one step further. So by that, we can do something like stats event count success by user. And then I believe by user. So now we can see that D Johnson, the guy who disconnected earlier, has had 121 failed passwords, although admittedly I think it's over like a few days. Still a suspicious number, and we'll get to that in a little bit. But you can tell, like, for the majority of users, mostly passwords accepted. However, for when there aren't any passwords accepted, or for alerting on when there is a suspicious amount of failed passwords, what we can do is, so again, count success by user and success. Let's see what that produces. So D Johnson has had 16 accepted passwords in 1 second, which is a little bit weird, but again, tutorial data, why not? What we then do is add a field that says alert if success is failed. So if the password is failed and it's had more than 5 failures, essentially. And then it'll produce a field called alert saying alert. So there you go. So D Johnson has had 7 failed alerts in that time. And what you could do afterwards is do something like send the email. This is the command email address. It will send you an email to this address with whatever subject, whatever message, and the results as a PDF. So then, if you have an ops team, it's quite good to have them on the lookout. Cool. So next, we will be going into SIEM, but being conscious of time, I might skip this bit. Essentially, it's about having the NIST compliance bit. Having the NIST, I guess, standard being fulfilled by the fact that information system endpoints, which is essentially what entry and exit points are being scanned for malicious code protection mechanisms. So essentially, like having security tools on your endpoints. And the way you do that is what I mentioned before, which is essentially compiling a list of your endpoints from the network logs, correlating it with it with other logs to make sure that you have like host names as well as IP addresses, and then having again having another list from whatever security tool you're using, and making sure that everything's being scanned the way it's meant to be. So Pci Dss, which is the bit that I mentioned I was working on earlier. We're going to use a sample standard because the logs have essentially they have a lot of login information, and that's like the primary security event logs that we have. So limit repeated access attempts by locking down the user ID after not more than 6 attempts. Fine, makes sense. So if we do that, and I no longer have to write out my Splunk queries, it's essentially looking at internal traffic, filtering out the user fields, internal IP fields, whether or not the password has been accepted or failed, and then counting, let's do that, counting the number of successes by users and by time. So how are we going to check that if there's more than 5 failures, get the alert? It's essentially building on what we did last time. So stats count should be familiar. So same as before, we've got some alerts where users have been failing passwords more than 5 times. So as per the PCI requirement. What we're going to add to that is essentially like a percentage. That's not good. Let's try that again. Stats. Let's see. Evaluate field. What did I do? Okay, cool. Last bit. Let's do something like not the worst bit if this doesn't work, because oh no, it's fine. So let's just remove that. So what we have is essentially an aggregation of the number of times that the word alert has come up in the alert field, and that's this bit. And then we're counting that as the number of alerts, we're counting the total number of events as the total, and then dividing the number of alerts by the total. And then we should get a, hopefully, oh, well, that didn't work for some reason. But anyway, the idea is classify the number of events that have had an alert and divide it by the total number of events, giving you a percentage for the Pci Dss compliance, where users have been limited by the more than 6 attempts, although clearly it's a setting that hasn't been switched on for this demo application, which honestly I probably wouldn't expect anyway. Cool. So moving on. Conscious of time. I will be done soon. Let's do the NIST one now. So the NIST one says that this is again what we've been talking about before, which is having the non-repudiation bit. Essentially protecting systems against an individual falsely denying having performed an action. Fine. So where we were looking at before, not having a user be able to deny having disconnected from a certain server. For example, if the server is compromised, it's quite important that they're the ones getting the disconnect. So what I've done here is essentially with the regex command from before, pulled up the user field. Fine. And then we can see that the number of users from this summary page is 75% of events have the user identified. Fine. So this is a slightly lazy way of doing it, but we're counting the number of events with D. Johnson, Mewen, and Sharp, and then counting the total of events. Cool. So number of events with users identified, that the total number of events is somewhere in the 2000 range. And then that should tell us that 75.137% of the events have the users identified, which is kind of like, yeah, it's good, fine, good web app. And then the last bit is for where you do have like a time chart. What you would do, I'm glad I already have this up, is you have the source from the secure logons, you have the failed password events, and then what you essentially do is track it by name over time. So, wow, it's slow. Anyway, the idea is you get a pattern with the time chart and use the forecast time series model, so Kalman filter, in order to be able to forecast. This is like failed logons by the admin, root users, things like that. And then you have, this is what we have at the moment. And at this point is where the model actually generates the predicted failed passwords, which it thinks is going to be 172 later on that evening. So yeah, hope that was helpful. That's pretty much it from me. Yeah.
Thanks very much for that. That was pretty cool. I think there's some questions coming in on Slido. I think some other people might have some other questions. So we have Anonymous, who the infamous hacker Anonymous, has asked on the PCI DSS example that you showed, is there a reason why you limited it to internal IPs only?
So with the web app that we're looking at, the demo tutorial data, the purchases by external users aren't, the users aren't identified. They don't need to have an account in order to be able to make a purchase, which is poor security decisions, obviously. But if we did look at external IPs, we wouldn't be able to track down the users. So a lot of the time, the work that I've been doing was tracking down internal users anyway. So yeah, that's why internal.
Cool. Awesome. Does anyone else have any questions in the chat? No, I think we're all good.
Nice.